Hi, welcome to our lesson on solving equations with variables on both sides. So far, most of the equations you've seen in school had something variable plus something equals something, and the variable only appeared on one side, and honestly, typically it's even on the left side. But in real life, that's not what happens. So one of the things we need to learn to do is what like terms can we combine? And then how do we do that if there's variables on both sides of an equation? So I wanted to start off with where we can combine like terms, and just kind of a review of that. And then how do we do that in an equation? So we need to remember that like terms have to have the same variable to the same power, 2x and 5x. If I have 2b squared, just b squared. This technically is 1b squared, but we never write the 1. It's invisible. Things that are not like terms, 2x and 2x squared, not the same thing. It's a same variable, but to a different power. 4x and 2xy. No, because even though they both have an x, this one also has a y. So just kind of going over that. In order to point that out, I have this series of terms right here, and I'd like to identify a few that are combinable. 2x squared. Well, I'm going to mark that one blue. Oh, and here we have a negative x squared. Okay. Xy. And then we have a positive xy there. We have a negative y. And notice it's not the same as xy. And we have a 2y. And then notice this guy here, he's a constant, has no variable, also has no other matches in here. So let's think about combining those. If I was to combine those, 2x squared and minus x squared. So I have 2 of something, 2 double stuffed Oreos, minus 1 double stuffed Oreo. Well, all I have left is 1 double stuffed Oreo. So that's these two that I've now combined. What about this one? 1xy plus 1xy. So one xylophone and another xylophone. Well, now I have 2 xylophones. Oops. And I need to mark that as, with the coefficient, 2 xylophones. Okay. Here I have negative yo-yo. I lost a yo-yo. I found 2 when I was cleaning my room. So I am now positive 1 yo-yo. Okay. And then plus 3 because it had no things to combine with it. So the purpose of this part is just reminding you of which things can be combined and which things can't. Let's get into an equation. So here we have an equation, and we need to follow all the regular rules. We can combine only like terms. What we do to one side of an equation, we have to do to the other. And we need to keep the equal sign lined up. That really helps for neatness and just kind of paying attention to the details. So if I wanted to start with the x's, with the variables, I have 6x on this side and I have 4x on this side. They're both positive values. So in order to move one of them to the other side of the equation, I'm going to have to subtract. I would rather subtract the smaller one because it's going to leave me with a positive value. And anytime I can work with less negatives, it makes life easier for me. So now 2x minus 9 equals, notice the -9 came down. These canceled out, and over here I just have 3. So now I've turned this into a two-step equation. Well, right now we have a coefficient 2 hanging out with x, and we have a -9. Well, this is a constant, and this is a constant, so they can be combined. The inverse operation of -9 is +9, so I'm going to add 9 to both sides of the equation. These cancel each other out, so I have 2x equals 12. Well, so now it's time to do the last thing. Now we're down to a one-step equation. 2 and x are being multiplied. X needs to be isolated. The inverse operation of multiplying by 2 is to divide by 2. So those cancel each other out. X is going to be equal to 12 divided by 2 is 6. So the value of x is 6. So as you can see, nothing different happens. We just need to make sure we're combining like terms. Now, one of the ways that you will see this fairly often is when we're trying to find out when things are going to be equal. So in this scenario, there's a couple of video games. One is rising in popularity, one is falling in popularity. Therefore, the prices are rising and falling. Game A costs $21, but the price is also going up $1.50 per week. So I could write that expression as 21 plus 1.5 W, 1.5 each week. My goal is, when is it going to be equal to this other game that costs $28, but it's going down $2 each week. So now I have an equation with variables on both sides. I chose to use W for the variable. You could use N or X or P. The variable just stands for the number. Now, I have to now look at this and decide, what do I want to do? I'm going to start with keeping all my things lined up, and then I'm going to look at this. Well, I have constants. 21 is smaller than 28, so I'm going to subtract 21 on both sides just to clean it up a little bit. It didn't really matter what thing I started with, we would get to the same conclusion. So now I have 1.5 W equals 28 minus 21 is 7 minus 2W. Okay. Now I really want to put the W's together. Well, I already have a 7 over here, so this is a negative 2W. Let's add 2W to each side. So now I have 3.5 W equals 7. Now I have 3.5 times W. Well, the inverse operation of multiplying is dividing. So divide 3.5W by 3.5. That's going to cancel that out. But you also have to divide 7 by 3.5. When that happens, W equals 2. So in 2 weeks, this game that's increasing in popularity and price is going to be equal to this game that's falling in popularity and price. We can do the same exact type of problem with speeds, things that catch up to one another, temperatures. I mean, anything that you're looking at for catching up to one another, this could help you find out when. So the answer here would be 2 weeks until they are equal. Okay. Hopefully that helps, gives you a little bit of insight and practice. And remember, on these equations, really, it does come with continuous practice is going to make you better. So if you're struggling, I can, provide, your teacher can provide things that would help you find these. Even something as simple as Khan Academy or a Google search of equations with variables on both sides will get you some really quality practice. Have a great day.